All right, good morning, everyone.
Good morning, sir.
It is indeed a blessing to be alive and to have the opportunity to actually share with you in this forum as I prepare for your examinations. Um, we know we have lost quite a number of instructional time, but the truth is we can make good with whatever it is that we have. And so I am happy that you are able to join with us this morning for a session that we intended to be interactive, a session that we hope and trust that you'll be able to learn something from, or even to improve or increase your competence as you prepare for your examinations. The truth is, those examinations will not be put off. So it makes absolutely no sense that we procrastinate, but instead put measures in place that we can use to sharpen our skills and so that we are able to perform successfully. I am going to ask you at this time just to bow your heads wherever you are so that I can offer a word of prayer. Our Heavenly Father and our God, we give you thanks for this morning. We give you thanks for life. We give you thanks, Lord, that you are interested in every single area of our lives. And as we have come in this fashion, Lord, to learn, we ask for a double portion of your wisdom, your knowledge, your understanding. That as your children would seek an opportunity to establish themselves in you, the one who has all knowledge, the one who has all power. We ask God that you will be with them as they go through this session, but more so, Lord God, be with them as they prepare for their examination. Grant them the success that you have in store for them according to your will. We ask for a blessing in Jesus' name. Amen. And so this morning, it is my intent, my desire to walk you through a past paper and to share with you some approaches that you will take or can take to actually score maximum marks in the examination. So we're not going to, you know, delay because we have just a short period of time. So we're going to get right into it and hope and trust that our friends will be able to join us as soon as they can, so that we can, of course, have a good time. We don't intend to be selfish. And so we want everybody who is able to join so that we can, together learn and impart the knowledge that God has given unto us. My name is Antoine Hardy. I am the president of the Savanamar District of Seventh-day Adventist Youth, and I will be your math presenter this morning. We ask you to join with us tomorrow for an English presentation, and then on the 30th of May for a social studies presentation, and then our final presentation in June 6th, that is, for a human and social biology presentation. So go spread the word, tell your friends, invite them, introduce them, and have them come to support as we learn together. So as you may know, this presentation or this series of activities is put on or promoted by the Savlanmar District Youth Federation. And our mission is to win everyone, one by one. And so today's presentation, as I said to you before, is going to be on mathematics, and I'll be your presenter. What are our objectives? To share ideas surrounding the approaches to mathematical reasoning. And this is key, this is important, because this is how you are going to be marked in the examination. It's not just about being able to compute, but you must be able to reason, you must logically think through what is it that is being presented to you. Compute effectively. And with effectiveness, it means accurate, logical, sequential. It means, therefore, that there must be a clear pathway starting from the question itself, leading to the final answer. Build competence around key areas of mathematics. Mathematics really is a building block. You are going to find concepts in every single area of mathematics connecting. And so if you build your competence around those key areas, then you will be able to do mathematics well. Improve your confidence through participation. I know many persons don't like to participate in presentations or participate in class because they may think that they don't have the right answer or that. It is important that you participate, because the more you share what is it that you know, whether it is right or wrong, it gives the person an opportunity to be able to guide you as to where your thoughts should be. So I ask that you participate. And let us have some fun. After all, it is Sunday, heading into Monday when the government will close us down for an entire 24 hours. So we intend to have some fun. Are you ready?
Yes, sir.
All right. So I have a Shakur Daily, I have Tyrone, I have Shauna, and I think there is Alia. All right. Numbers are not important. We just want to ensure that we have. And so here comes the first question. And the first question generally is a simple question with the hope that it gives you an opportunity to score some mark and build your confidence as you go along. So it says, using a calculator or otherwise, calculate the exact value of 1 and 4 over 7 plus 2 over 3 minus 1 and 5 over 6. Importantly, the instruction says using a calculator. How many of you have a scientific calculator that can help you to answer a question like this, or even know how to plug this question into your scientific calculator? All right. So your calculator can simply provide you with this answer in just one shot. However, it is important for you to understand that it is not just about using your calculator. You must show all the working. So the catch in it is using the calculator, but the logical sequence of activities must take place as well. All right. So here we have two mixed numbers and a proper fraction, and they are basically sharing the operations of addition and subtraction. Now, you must know by now that when you are adding or subtracting fractions, they take the same process. If the denominators are different, we find an LCM. But if the denominators are the same, we can simply just add and subtract as they appear. In this case, we have 3 denominators. And our 3 denominators are 7, 3, and 6, which makes them different. All right, so it means therefore that somewhere within the process, we will have to find an LCM. Now I want to share with you at this point that we do not find LCM for multiplication, and we do not find LCM if we're dividing a fraction. It's important for us to understand that the only time we find LCM is when we're adding or subtracting. And because of the fact that the same process is taking place and they are basically using the same technique, we can just treat the one problem as just one single set of working. You know, what do I mean by that? If I had something like multiplication or division inside the problem, then I would have had to, at some point, use parentheses to separate them so I order the operations effectively. All right. here we have our solution. Now we're going to first change our, the first thing that we're going to do is to change our improper fraction, sorry, our mixed number into a improper fraction. So 1 and 4 over 7 is actually 7 times 1 plus 4, and that becomes the numerator. And again, we put it back over the denominator. And then 7 ones give me 7 plus 4 gives me 11 over 7. We don't have to do anything with the 2 over 3 because it already is a single fraction. So we don't want to operate with the mixed numbers like that, where we have a whole number and a fraction. So we convert it into a improper fraction. Likewise, 1 and 5 over 6. 6 times 1 plus 5 gives us 11 over 6. And again, we're adding and subtracting. Now, 7, 3, and 6, they are different. And so we want to find a number that will make each of them having equal proportions. And so we find the LCM, which is 42. What that simply tells us is that when all the fractions are shared into portions of 42, then each portion would be equal. And that is what the LCM does. The LCM makes the amount in total of each fraction be the same so that they can be shared and look equally. All right. Now, 7 into 42 goes 6 times. Hence, we multiply the numerator 11 by 6. 3 into 42 goes 14 times. And hence, we multiply the numerator 2 by 14. 6 into 42 goes 7 times. And hence, we multiply the numerator 11 by 7. Now, completing our process, 6 times 11 gives us 66, 14 times 2 gives us 28, and 7 times 11 gives us 77. We must bear in mind that we are adding and we're subtracting, and so we must keep the operations in their respective places. All right? Now we have 66 plus 28 minus 77 over 42. Can anybody just simply finish that and tell me what is their answer? Tyrone, you want to tell me what's the final answer? All right, so Tyrone Shauna said 17 out of 42 or 17 over 42. Do you agree with her?
Yes, sir.
Mm-hmm. All right, so you agree with her? So that's 17 over 42. Very good. All right. Now, the second question says, and so, I mean, we're able to get all of that marks and we must feel confident now going to the next question saying, yes. One thing I must remind you is that your examination has 10 questions and all 10 questions must be done. I must also share with you that your examination is to be done in 2 hours and 45 minutes. So you have 2 hours and 45 minutes to do 10 questions. So time is of the essence, and we must ensure that we practice, 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 practice. All right, so it says write the value of the cube root of 27 over 9 squared as a fraction in its lowest terms. Now, when we speak of square root, we speak of multiplying two identical numbers to give you a number. So 9. The square of 9 is 81. And so the square root of 81 is 9 times 9. Now, when we speak of the cube root, we follow the same process, but in this time, we're not going to be speaking of multiplying an identical number twice. We'll be looking at multiplying an identical number 3 times. So that's what we speak of when we speak of the cube root. Now, can you tell me of any number that you can multiply 3 times the identical number that can give you 27? No, not yet. Let us try. Let us try 1. We're going to multiply some numbers 3 times, some identical numbers 3 times, and see what we get. 1 times 1 times 1, what do you get? Alia? Is Alia here?
Yes, sir.
What do you get when we multiply 1 times 1 times 1?
1.
We get 1. Good. So we don't get 27 yet. Good. What do we multiply? What do we get when we multiply 2 by 2 by 2? Shakur.
Say that again, sir.
What do we get when we multiply 2 times 2 times 2?
Six, sir.
All right, so let us try it again. 2 times 2?
Yes, sir, sorry.
You got 8. All right, awesome, son. No problem.
All
All right, good. So 2 times 2 is 4, and 4 times 2 gives us 8. Tyrone, 3 times 3 times 3, what do you get?
27.
27. Therefore, the cube root of 27 is 3. The cube root of 8 is 2. And the cube root of 1 is 1. We need to know those basic information in preparation for the examination. All right. And so, yes, we know the cube root of 27 is 3, as Tyrone has just given to us. And the square of 9 is 9 times 9. Now, here we have a fraction, which is 3 over 9 times 9. How do you think we move from 3 over 9 times 9 to 1 over 27? What do you think the process was? The numerator is 1, and the denominator is now 27. What do you think happened? Shauna. Shauna, are you there? All right. So Shauna is typing in the chat. All right, so Shauna said we simplify. Okay, fine. Can anybody help Shauna? Yes, we simplified. But how did we simplify? Can anybody help Shauna? What did we use to simplify?
Sir, it would be 3 over 81, right?
Yes.
So we divided 3 into 81, and we got 1 over 27.
All right, very good. All right, so that's one way to look at it, and very good. We could also say 3 into itself one time and into one of the 9s. How many times? 3. And then 3 times 9 gives us 27. So that's another way that we could look at it. So as Shauna said, 9 times 9 gives us 81. And so 3 into itself one time and into 81, 27. Or we could take probably a little simpler step. 3 into itself 1 and into one of the 9s 3 times, and then we're left with 3 times 9. We will still get 27. All right, very good. All right. So the thickness of one sheet of cardboard is given as 485 times 10 to the negative 2 millimeter. A construction worker uses 75 sheets of the cardboard stacked together to insulate a wall. Show that the exact thickness of the insulation is 363.75 millimeter. Now look at this question. The answer is already given. What is required of you is to prove from all the information that you have and the calculations that you will use that you will get back that same exact answer. So CXC is not interested in the final answer. What they're interested in is the process that you will take to prove to them that it is correct. So I know many students have the tendency to think through the question in their mind and just put down the answer and believe that it is going to be marked and they get maximum marks. No, you will have to show the working. And here is a perfect example that you are required to show that the answer is correct. Now, the thickness of the insulation is given by 485 times 10 to the negative 2. And how many of them do we have? How many of them do we have? 75. That's what the question says, right? 75 sheets. Will each sheet have the same construction, makeup? It says the thickness of one sheet is 485 times 10 to the negative 2. And you are stacking together 75 of them. Is my information or my process therefore correct to say 485 times 10 to the negative 2 times 75? Are you agreeing with my process, or you think that's not how it's supposed to be done? Lenny? Is Lenny there? I don't want you to just come and have me alone talking, you know. All right, so yes. Now, if you further look at the problem, we end up with 36,375 times 10 to the negative 2. What do you think happened? It's going to be a little bit difficult for me to manage the chat and the presentation at the same time, but I would love if you would just open your microphone and talk. I had 485 times 10 to the negative 2 times 75. Now I have 36,375 times 10 to the negative 2. What happened? You don't plan to talk to me today? All right. So what we did was to multiply the... All right, go ahead, Shauna.
Sir, I was asking if you could repeat the question because I didn't hear you.
All right, so I was asking, we move from 485 times 10 to the negative 2 times 75 to 36,375 times 10 to the negative 2. What happened in that process? How did I just automatically come with 36,375?
Sir, we multiply 75 by 485.
All right, very good. Now, one thing I want you to understand, students, is the principle of commutativity. Now, you'll probably say, okay, fine, but the multiplication sign is at 10 to the negative 2 with 485. So why did I jump all the way to the back and take 45? Now, multiplication is commutative, which means, therefore, that if I say 485 times 10 to the negative 2 and then multiply by 75 is the same thing as saying 485 times 75, then by 10 to the negative 2, or 10 to the negative 2 times 75 times 485, I will still get back the same answer. That's what the commutativity rule states in mathematics. Whatever pairs you multiply, it will still give you the same answer if you multiply. So it's almost like 2 times 3 gives you 6 is the same thing as 3 times 2 giving you 6. So the order does not matter once it is that we're multiplying. All right. Now, 10 to the negative 2 tells us that we need to shift our decimal point 2 places to the left. Now, in a whole number, my decimal point will be at the end of the last digit or at the end of the ones position. So technically, my decimal point is behind the 5. If I move it 2 places to the left, then it is going to come between the 3 and the 7. Now, when I put it 2 places to the left and between the 3 and the 7, I automatically get 363.75. What did the question say that my answer is supposed to be? 363.75. And so I can now say that I have proven that the thickness is actually 363.75 millimeter. So if I had just thrown down, yes, it is 363.75, I will get no marks in the examination. All right, let us continue. It says you have to write the thickness of the insulation correct to 2 significant figures. So in significant figures, what we're looking for is the first 2 digits that are not 0. In this case, the first 2 digits that are not 0 is the first 3 and the 6. Now, one thing I want you to understand, we always look at the digit after to decide whether it is that we add a 1 or we leave it alone. And so because this digit is less than 5, we will leave it alone. But we must also understand that when we're representing significant figures in whole numbers, all the place values must be accounted for. So here I had 363, and I'm only taking out 2 of the significant figures, which would be the first 2, which is 36. Would 36 be a close representation of my original number, 363? Yes or no?
No, sir.
No. So what I simply have to do is to ensure that every single place value is represented. So I must still hear in my number 300. I must hear the hundreds position. So in terms of just taking the first 2 digits and say 36, there is no longer any hundreds in the statement. And so I have to use a 0 as placeholder for the units or the ones position. Hence, my answer becomes 360 millimeter expressed as two significant figures. Importantly, students, do not leave out the part in the bracket that tells what is it that you're doing. So don't just write down 360 millimeter and leave it like that. Please express to the amount of decimal places or significant figures in bracket that the question requires or that you are making a decision for yourself. It helps the marker to understand where your thought process is going. All right. Now, correct to one decimal place. We're going to go back to the very same answer. So we're not changing. So now we're not going to look at 360 because we round it already. We're going back to the original question or the original answer, 363.75. So it says 363.75 and we want one decimal place, which means that it is one digit after the decimal point. So here we have a 7, and now the deciding digit becomes the 5. Now notice that it is now 5. And so once it is 5 or more, we must add 1. And in adding 1, my answer now becomes 363.8. And again in bracket, correct to one decimal place. It's important. I can't overemphasize it. We must state, especially when we're approximating answers, we must state the approximation that we're using. It's very important. All right, so we'll go to the next part of the question. And so the next part of the question says, we are to express the answer in standard form. Now we know that standard form has this particular principle, A times 10 raised to the power n, where A is any number from 1 to 9, meaning that only one digit can be before the decimal point, and it cannot be a 0. It must be from 1 to 9. And so 10 to the nth power represents the multiplicator that will give us our original number, with n telling us if we were supposed to alter it, how many places did we move to make the alteration, all right? And so again, our original number is 363.75. Now, there are 3 digits before the decimal point, and we say that A can only have 1 digit before the decimal point. And so in this case, what we have to do is to move our decimal point 2 places so that it falls between the 3 and the 6. Now, when it falls between the 3 and the 6, our answer now becomes 3.6375 times 10, and n now, which would be in this case the number of movements that we take, becomes 2. So we move 1, 2, and we move on, where numbers are still a whole number, our number is still greater than 0, and so we have a positive 2. All right. Now, if you look at this, what do you think happened right here? So I have 3.6375 times 10 to the 2, and it says or 3.638 times 10 to the 2, or 3.64 times 10 to the 2, or 3.6 times 10 to the 2. What do you think is happening with all of these answers? Anybody? All right, so in this case, we are approximating our answers. So in this one, we had 4 decimal places. In this one, we now have 3. In this one, we have 2. In this one, we have 1. But if you recognize the movement or n or the exponent still remains 2. So that is key, that is critical. Still only 1 digit is before the decimal point, which is the 3. But we're approximating the number of decimal places. And so when we're marking, if you give us reasonable answers, we're able to look at the work that you're doing to give you the marks. All right, so we move on. It says Marco is on vacation in the Caribbean. He changes 4,500 Mexican pesos to Eastern Caribbean dollars, and he receives 630 Eastern Caribbean dollars. We're to complete the statement below about the exchange rate. We want to find out what 1 Eastern Caribbean dollar is equivalent to in Mexican dollars. That's what the question is asking you. How would you approach this question? You want to find out what 1 EC dollar is in equivalence to Mexican dollar. How would you approach the question? Anybody?
So we would multiply.
All right, you would multiply. All right. Anybody else? Shanicia, how would you approach the question? All right, so Shauna, you went to school and you bought some cocoa breads and you paid $500 for it. Say you bought 5 cocoa breads. How would you know the amount of money you pay for one? What operation would you use? You bought 5 cocoa breads, you paid $500 in total. How would you know how much one costs?
Sir, to know how much one costs, I would have to divide.
You'd have to divide. Very good. All right. Very good. So 630 Eastern Caribbean dollars is equal to 4,500 Mexican dollar. And so we want to find out what 1 Eastern Caribbean dollar is. And so just like this situation with the cocoa bread, we must divide to find out what that is. So it is $4,500 divided by 630, and that gives us $7.1428, and I'm saying $7.1428 because we know in normal currency that we approximate money to dollars and cents. So the most appropriate answer would have been 7.14. 7.14 because we're looking at dollars and cents. Now, for me to say 7.14, I would have to stop at the 4, but I look at the 2. The 2 will not bear any significance. So it will not change because it's less than 5. So it's 7.14. The 8 changes the 2 because it is greater than 5. But if I was supposed to just stop it at dollars and cents, $7.14, then I would be correct. And I could say to the nearest cents, or I could simply say correct to 2 decimal places. We must always, if you recognize, the question did not ask you to approximate to any given figure, but in our common knowledge, we know that we need to do some approximation because we're talking about money. So in this case, I wrote correct to 3 decimal places, but it would have been safer to say correct to the nearest cents or correct to 2 decimal places. All right, so we are touching a little bit into algebra now, and it says that you're to factorize the following expression completely. 12n squared minus 4mn. And so there are some factorizations that you're going to have to contend with as you prepare for your examination. Factorization using the HCF method, highest common factor. Factorization using difference of 2 squares. Factorization utilizing grouping, where you have 4 terms and you put them in pairs. Or quadratic factorization, all right? So in this case, 12n squared minus 4mn, and we recognize that whilst it is that n is squared and 4 can be a square number, 12 is not square and mn is not square, so that throws the difference of 2 squares out. So now we look for the highest common factor. The highest common factor among these 2 terms is 4 can go into 4 and 12, and n can go into mn and n squared. So 4n becomes the common factor. So now we look for, what do I multiply 4n by to get 12n squared? And so we would need to multiply it by 3n. What do I multiply 4n by to get 4mn? And that would have been m. And so since as 4n is common to both terms, then it is a common factor to 3n and m. And so we just put it simply in a bracket by themselves. So 3n comes down, the minus sign comes down, and the m comes down. If we should expand this bracket, 4n times 3n gives us 12n squared, and 4n times minus m gives us minus 4mn. Any question? This time you can type in the chat. Any question? All right, so we move to the next question. And the next question says, we're to show that x divided by 1 minus x subtracting 4x is equal to 4 bracket 4x minus 3 divided by 1 over x. Again, the answer is provided, and this is how CSEC has been treating their questions. The answer is given. The process is what you need to provide. So here we have a little solution. All right. So x over 1 minus x minus 4x can be written as x over 1 minus x minus 4x over 1. And now we recognize that we have a fraction that we started out with, and now we're back again with fraction, but in a different form. We find the LCM because of the fact that the denominator LCM of 1 minus x and 1 is simply 1 minus x. Now again, 1 minus x into 1 minus x goes 1 time, and we multiply the numerator x by 1. 1 into 1 minus x goes 1 minus x times. And so we multiply the numerator, which is 4x, by 1 minus x. Now, why did I put the 1 minus x in the bracket and the 4x on the outside? Because in order to distribute, it's easier for me to distribute the 4x to the two terms in the bracket than to distribute the two terms to 4x. All right. I may be confused to think that only the x should be distributed, but I put the two terms in the bracket so that I know that 4x should multiply both of them. And so we get 1 times x being x minus 4x times 1 gives us minus 4x, and minus 4x times minus x gives us positive 4x squared. And we divide that by 1 minus x. Now, in simplifying this, we recognize that x and minus 4x are common. So this basically being 1x minus 4x leaves us with minus 3x. And to write the problem with the positive properties first, we end up getting 4x squared minus 3x. And so we divide that now by the denominator or the LCM that we had first gotten, 1 minus x. Further again, we factorize. What is common to 4x squared and minus 3x? We should note that that is x. So what do I multiply x by to get 4x squared? 4x. What do I multiply x by to get minus 3x? And that would have been 3. Now, x is common to both terms, so x goes by itself, and 4x minus 3 goes in a bracket by itself. And we divide that by 1 minus x. And ta-da, we come back to the very same answer that the question started out telling us that we must prove to be correct. Any question? All right. I hope we have not left to go and have breakfast and leave me here talking alone, you know. All right, it says, hence solve the equation. Now, I want to share with you or help you to understand what does the word hence in a question in mathematics mean. Hence means the part that you just solve must be used to solve this part of the question. I see, it's all right, man. I catch you, Tariq. You look like you just get your breakfast. All right. But at any point in time, if you feel like you need to ask a question, don't be afraid to ask it. All right. So hence means whatever solution we just got is what is it that we're supposed to use. And so if you look at the part A and part B, we were working with expressions. Now part 2 says that we're to solve. And so you now see an introduction equal to 0. All right, so we take back the same question as is shown in the part over there, part 1, x over 1 minus x minus 4x is equal to x bracket 4x minus 3. And so all of this came from here, and we had proven it to be correct. So what we need to do now is to make it into an equation and solve it. So in order for us to solve it, we need to get rid of the denominator to make it linear. And so we're going to multiply both sides by 1 minus x. Now, when I multiply this side or the left side by 1 minus x, the 1 minus x will cancel. And so I'll be left with x bracket 4x minus 3. And then I need to multiply the 0 by 1 minus x. but we know that multiplying anything by 0 is going to give us 0. And so what we simply need to do now is to solve. Now we have two terms in the problem that is equal to 0. X is equal to 0, which is already solved. So we just simply say x is equal to 0. And that's a solution. We take the factor on the outside and equate it to 0, and that becomes a solution. There's no further working for that. Now we have 4x minus 3, which is another factor, and that is equal to 0. In this case, we need to solve a little further. We need to make x the subject. So in making x the subject, minus 3 is transposed to positive 3, or minus 3 is transposed to plus 3. And 4x multiplied by 4 is transposed to be divided by 4. Hence, we have x is equal to 3 over 4. So in one case, x is equal to 0. And in solving for x, we get x being 3 over 4. And since we spoke of transposition, if you look at how the questions keep following in terms of pattern, we started from factorization, just a simple expression. Then we come down and we go back to the first question, which was fraction, then put in a little factorization, then come over to solving, which had a little bit of factorization as well, and solutions being done through transposition now takes you to the next question that says that you have to make V the subject of the formula. So if we have the logical sequence coming down, then each part of the question follows a particular order that helps us to answer the next part. So in order for us to solve, V is under the square root sign, and so we need to free it up. There is no way that we can work with V being contained under the square root sign. And so what we simply do is to square both sides to remove the square root sign. The opposite of squaring is taking the square root. And so the square and the square root will cancel each other on the right side, and P will now become P squared. And so what we start to do now is to move things around by rearranging or reordering their operation. So because we want V as a subject, P squared is equal to 5 plus VT is the same thing as 5 plus VT is equal to P squared. There's no swapping yet. They are both the same. P squared is equal, because I can read it, P squared is equal to 5 plus VT, and I can read it, P squared is equal to 5 plus VT. So no swapping has yet taken place. Now, I have to remove everything that is not connected to V first in order to free up V. So 5 stands by itself. And so I take the inverse of 5, which becomes minus 5. Now I can remove what is connected with V here. And so VT is a multiplication. Hence, I remove T by the reverse process, which is T. Sorry, divide by T. Now note, I am not dividing the 5 alone by T. I'm dividing everything that is on the right side by T. So P squared was there before, and then I remove the 5, it becomes minus 5. And don't say because only 5 and T was over on the left side, so I'm only going to put the T where 5 is. No, we're putting it in the entire process. 5 squared minus P squared rather minus 5 divided by T. And that completes the process because V is isolated, V is by itself, and that is how we would solve or make V the subject of the formula. Making something the subject of the formula is really writing it as an expression or solving it, just as in the case of X in the previous part of the question. All right. It says the distance needed to stop a car, D, varies directly as the square of the speed, S, at which it is traveling. A car traveling at a speed of 70 kilometers per hour requires a distance of 40 miles to make a stop. What distance is required to stop a car traveling at 80 kilometers per hour? Now, there's some key information in this that we need to pick out. It varies directly as the square of the speed. What that simply means, what directly means is that one changes in the same order as the other changes. If one increase, the other increase. If one decrease, the other decrease. That's what it means by directly varying or proportionate. Now, we're given information about one particular. So we get a speed, which is 70 kilometers, and we get a distance, which is 40. Now, that information is supposed to help us to find what is the constant or K in the question to determine how to approach the next part of the question. And so this little symbol right here, without the vertical line beside it, is a symbol for variation. So D varies directly as the square of S. And so that's important. You must allow the examiner, the marker, to know that you know what you're talking about. So D varies directly as a square of S. And why it is written like this for direct, indirect variation will be written as a fraction. All right. So because it's written like this, it is already assumed to be a direct variation.
So,
now,
sir,
as I said to you, yes, go ahead.
if it was indirect, right, it would be 1 over S squared?
1 over S squared.
Okay.
Or some other information that it may give to you. Very good.
Okay.
All right. So D is equal to K S squared because there must be some constant that is taking place in the proportion. All right. So I want to know how much money to spend for the cocoa bread that I'm buying for lunch at school. All right. So the total money is equal to how much I am buying times what one costs. So K would be the cost of one, and then now the other variation now would come from the amount that I'm buying. So K remains constant because one cocoa bread is just $100. If I'm buying 5, then my total amount is going to be 100 times 5, 500. If I'm buying 3, 100 times 3 is 300. So if you recognize I bought 5, the money went up. I bought 3, the money went down. Direct variation, but the constant K would have been the price of the cocoa bread. So there must be a constant that is taking place. So we use the information that we know to find the value of K. And so in this case, we say that 40, which is the distance, because remember the distance is called D, so we're just basically substituting. 40 is equal to K, which we don't know, times 70, which is the speed, and we square that. Now, because we want to find K, all we simply need to do is to transpose. You see how everything following one behind the other? So we're going to leave K by itself, and to remove it being multiplied by 70 square. And so we have 40 divided by 70 square being the constant K. Are you with me?
Yes, sir.
All right. Like when you get breakfast, man, when I talk, you know. Lenny, your belly full? All right, look like him still.
Yes, sir.
All right. So, Alia, your belly full? Hungry still about Noble? All right, Papa. All right.
Yes, sir.
Okay, so Alia had something. Noble, look at me, I alone have nothing to eat, Papa. Like we'll probably have to go visit Alia and Lenny and get some food. All right. So now we are asked to find the value of or the distance when we have a speed of 80 kilometers. All right. So since we know that the distance is equal to k, which is 40 over 70 square times the speed square, then we can just put in the information that we have, substitute. When S equals 80, and if you recognize students, I'm answering my questions and I'm not just throwing down information. I am having a logical conversation. I'm telling them what is it that I'm doing. So when S is equal to 80, which is the information that I'm getting, D is going to be equal to K 40 over 70 square times 80 square. Accurate substitution. Because I could simply just mess it up and say, okay, I'm putting 80 here and 70 here. Then that would be incorrect, even though I'm using information that I know, because they must be placed in their correct position. All right. So we can multiply the numerators because 80 squared is a numerator. We can just simply write it over 1. And so this becomes 40 times 80 because 80 squared is 80 times 80. And then 70 squared is 70 times 70. And throwing all of that in my calculator, I get 52.244. And so my approximate answer is 52.24. Again, deciding number is less than 5, so it does not change anything. I don't need to add 1. And again, I state that my answer is correct to 2 decimal places. Are we good with that?
Yes, sir. But sir, can you scroll back up a little bit, please? Let me see the question one more time.
Okay. All right, sure.
Okay, sir. Thanks.
All right. So we continue. It says the diagram are we there? Can somebody read the question for me?
The diagram below shows 2 pentagons, P and Q, drawn on a grid made up of squares. Select the correct word from the following list to complete the statement below.
All right. So looking at the diagrams, can we say that they're opposite?
No, sir.
All right, no. Opposite means that they are 2 different things, or the difference of the same, put it that way. Makes absolutely no sense, but they're not opposite. Are they reflected? Are they reflected?
It's possible, sir.
It is possible. All
Mhm.
right. Are they congruent? All right, so I may need to explain that word a little. All right. Are they translated?
Sir, no, sir.
All right. So let us probably look at reflected and translated in a little bit more of information before I, look at all the words together. When something is translated, it simply means that you take it from one location just as it is and put it somewhere else. So if we look, Q is standing, so to speak, and P is tilted. That would not be a translation because all it would simply mean that for Q would still need to look the very same way that P looks, but just in a different location. For reflected, it would simply mean that Q would be looking back at P, and Q does not seem to be looking. Take, for example, yourself looking in the mirror. When you look in the mirror, does your body continue to look down, or does it turn around and look back at you?
Sir, it's a reflection, so
It turns around and look at you.
right.
Yes. I mean, you all know everybody depend Snapchat or TikTok or whatever it is. Or when we're taking selfie with we bestie. When you look in the camera, the camera shows yourself looking back at you. You really have me here looking in my phone too. So you have your camera looking back at you. Now, in looking back at you, it means therefore that a reflection is taking place. So neither of these two shows a translation or shows a reflection. Now, but what does the word congruent mean? Congruent means exactly the same, irrespective of its orientation. Same size, same area, same angles, same length of sides, same number of sides. Congruent means that they are exactly the same, and it does not mean if them topple over or if them set in a different way. Of the four words, which do you think would best represent pentagon P and pentagon Q?
Sir, in this case, it seems to be congruent. Then we don't know if to explain.
All
Hopefully,
right, so,
call the word.
all right, so the word is congruent. So there are two words. So there's a similar shape and there's congruent. Congruent means exact. Similar means that they are the same shape, but they can have different sizes. So we need to know those two things because they are critical. All right, so it's congruent. If you look, this size right here have the same length as this side. This side right here have the same length as this side. And if you go through this shape, they both have 5 sides and all 5 sides are the same. And if all 5 sides are the same, all angles formed will also be the same, congruent. Now, you just said that you are not sure how to explain it, but trust me, CXC has moved away from just simply you calculating. Now, this is some information that you needed to know. Now, here is the question that becomes the literature part of mathematics. Give the reason for your choice. So you can't just choose congruent and leave it right there. You must say, why is it that it is congruent and not the others? And so I probably put a little thing right here that you can summarize. It says the 5 sides of P are equal in length to the corresponding 5 sides of Q, hence the figures are congruent. Do you agree with that?
Yes, sir.
All right, good. Or we could say both pentagons have the same shape and exact in their size, and their areas are both equal to 8.5 square units. So we can count it up. So 1, 2, 3, 4, 5, 6, 7. This is going to be 8 with this little part right here, 8.5. And so this will also be 8.5 as well. All right. So whatever information that we can use to prove, then we need to give reason for our answer. So we can't just say, I don't know how to explain it. We're gonna have to try and do some explanation, man. All right. And so it's important that we understand how the questions follow as well, because now we're going to have to be using some sort of reasoning to get through this part of the question. It says that we're to determine the value of W, X, Y. Now, when we have angles being named this way, the one in the middle is the one that does the talking. So we have W, X, which would have been this side, WX, and then we have XY, which would have been this side, and the angle that is formed right here comes in the middle because that's the point that is shared common to both line segments. All right, so this is WXY. So we want to find out what this angle here is. All right, now importantly, we have to try and use the information on the diagram. So we see this little symbol right here and this little symbol right here. What this simply means is that these two lines are parallel. So too, we have this symbol right here and this symbol right here, which tells us that these two lines are parallel. Now, this line, if this is parallel, then this line is considered to be a transversal. That if we extend this line, we'll form some angles right here. And if we extend this line, we'll form some angles right here. So too would have been ZY and WX. XY would be a transversal cutting those two lines. And there's some important information that we can get when parallel lines are cut by a transversal. We can get co-interior angles, we can get alternate angles, we can get vertically opposite angles, we can get corresponding angles. We will not necessarily be going through all of them, but I want you to bear those things in mind in your revision. You may want to write them down, that you look back at them, so that you have an understanding, an idea of what is it that you can look at. So we're looking at angle X. Now, I have put all the angles together in a little diagram. And as I said to you before, remember, if we extended this line, we'd see angles formed right here. Now, in this little C right here, we have two angles that are supplementary. They are within the C. So this angle right here in this part of the C, and this angle right here in this part of the C, they are supplementary, which means that they add up to an 8 degree. And we call them co-interior angles. All right. Now, co-interior angles sum up to 180 degrees. So we're going to be looking for V, W, and X. Now, in this case, we're looking for angle W. So we say that we know that the two angles, and let me go back again, just so. These two angles must add up to give us 180. These two angles, again, if you look, here is another C because we're looking at the parallel lines. The reason I'm able to identify 114 or Y and X the reason I'm able to identify Y and X is because of the parallel lines that are represented here and the transversal YX. Those two angles will supplement each other to become 180. So too is the parallel line VW and YX cut by the transversal WX. These two angles are supplementary. And so they should all add up to 180. All right. So we say x, zy, x plus wxy is equal to 100. And we say that they are co-interior angles. Therefore, 114 plus wxy is equal to 180 degrees. And wxy is equal to 180 minus 114, which is 66. Likewise, if that is the case, xwv plus wxy should give us 180, and xwv is equal to 180 minus 66, which gives us 114. And they are both co-interior angles. And because they are co-interior angles, we say that they are supplementary. And by supplementary, we mean that they sum to 180 degrees. Now, there's a final angle inside the polygon. We know 4 already, but the truth is we don't know what is the total amount of angles in the entire polygon. And so now we have to go to find the total sum of angles in the polygon. And that is given by the standard formula, 2x minus 4 times 90 degrees. So that's a standard formula for any polygon at all. Now, the x represents the number of sides. How many sides does a pentagon have? All right. So a pentagon has 5 sides. So 2 times 5 gives us 10. And 10 minus 4 gives us 6. And 6 times 90 gives us 540. So we know that the total angles in the polygon should be 540. Hence, to find the final angle, it would have been 540 minus all the other angles that we know. The 2 that came in the problem, the 2 that we just calculated, and so we'll get 148. I will go back to the diagram again, and we see where they are. This is the 148 we found by finding the total angles in the polygon. We subtracted the 98 and the 114, which came in the problem, and then the 66 and the 114 that we had already calculated from the previous steps. And so we get 540 minus all of these added together, and we get 148. All right. So here we have, it says the letter A and a point C66 are shown on the grid below. We're asked to enlarge the letter A by the scale factor about center C66. And there's a simple process to do this. All we simply need to do is to extend all the points to the center from the from A and extend it down to form the larger shape. Now, if you notice, basically from A to the point C, the length of the line is 2 units. And if the scale factor is 2, then from point C to the larger shape should be 4 units. So the length of the line should double. Are you with me? Anybody there?
Yes, sir.
All right. So the length of the line is 2 units. And so to multiply that or enlarge that 2 units, we get 4 units. But both the object and the image must be coming from the center. And so we get 4 units and we stop our line right there. And we do the same thing for all the other points. And so you have to invest yourself in a pencil and a ruler, especially a 12-inch ruler, because that is what you're going to need for your, your examination. So it says we draw lines from the point 6, to each of the 3 endpoints or vertices of the given figure A shown in black. And then we extend these lines shown dotted to 2 times their lengths, since the scale factor is 2. And that we're to note that all measurements are taken from the center, which is the same thing that I was saying to you. Doesn't matter if you're looking at the object or the image, it must be coming from the center. So you don't say from here to here is 2, and then you're going to say, okay, it is going to be 4. So from here to here, I'm going to find 4. No, it must come back again from the origin or from the center. All right. All right, so the question says the translation of letter A using the vector T. And what that simply means is that we're going to take the letter A and put it somewhere else by the vector T. And so from the vector T, we can each vertex of the object is to be shifted 3 units horizontally to the left because it's -3. And 2 units vertically upwards because it is positive. And we can do that either by calculation, or we can just simply move it. All right. So if you take this point, you'll recognize that it comes 1, 2, 3 places to the left, and then it went 2 places up. This point should also move the same way. 1, 2, 3 places to the left, then 2 places up. This point as well should come 1, 2, 3 places to the left, then 2 places up. And then we just form our A. And if you look, it's the same A, it's just that it is in a different location. And that is what we speak about when we say we translate a particular shape. Any question? Welcome, Mr. Horton. Is there any question that you have?
Sir, I'm kind of confused about how the translation, like, just a little bit, sir. What
All right.
kind of?
Yeah, man. So let me go back to it. And don't sit there if you don't understand here, please.
Yes, sir.
Me not turn monster yet. All right. All right. So this is my original shape, and I'm told that I need to translate it using this vector, -3 and 2. -3 means that I'm moving on my x-axis or a horizontal movement. Because it's negative, I'm going to the left. If it was positive, I would be going to the right. The top number tells only how to move horizontally. Now, the bottom number tells us how to move on the y-axis, or up or down. If it is positive, we go up, but if it's negative, we go down. So here is my shape. My original point right here means that I'm going to go 3 places to the left. We could actually calculate it. The x value right here is 4. Take off 3 off 4 and tell me what you get.
One.
And so if you recognize, the point is right at 1. You see it right at 1? See it there, right at 1. Because it moved 1, 2, 3 places to the left. So here it is. This point is 3. When I take 3 from it, what do I get?
0.
0. And so if you look at the point, it is at 0 on the x-axis. Just as though if I move 1, 2, 3 places, I'm going to end up at 0. Any clearer to you?
Yes, sir.
All right, I appreciate it. All right, so here we have a diagram. It says the function f is defined as f of x such that x is mapped to 3 minus 2x. And the diagram below shows the mapping diagram of the function f, and we're asked to find the value of a. And so this is just a simple substitution. All right. So a is that we're going to substitute a. So a is equal to f of -1 in the function. And so wherever we see x, we're going to put -1. So here we have a is equal to 3 coming from the function minus 2, and then the x is now changed to -1. I will perform that operation. Minus 2 times -1 gives us +2, and 3 plus 2 gives us 5. So a is equal to 5. Simple mathematics. You have to determine in the simplest form the expression for the inverse of the function. So we want to repeal this process, or we want to transpose it so that we introduce a y and y becomes the subject. So basically we're moving all the operations that we can see clearly and make them the opposite operations. So the first thing that we do is to let y be the subject. So instead of having f of x now, we change the f of x to y. So it now becomes y is equal to 3 minus 2x. To obtain the inverse of the function, we interchange the x and the y. So if you look, I now have x is equal to 3 minus 2y. So where the x was, the y goes there, and where the y was, the x goes there. And then now we're going to make y the subject. So in making y the subject, I can't have a negative y. So what I did was to remove minus 2y alone, and I brought it over to the left side. It becomes positive 2y. Moving x, because x is not the subject, it can be positive or negative. So moving x over to the next side of the equation, or switching the side it's on, it becomes minus x. So now it is 2y is equal to 3 minus x. And so I don't need 2y. What I need is y. So the multiplicative operation happening right here, or the multiplication happening right here, I need to do the reverse, which is to divide. and I divide by 2. And again, because 3 minus 2x is from the previous step, I need to divide everything by 2. And the final step, use the inverse notation. F inverse x is equal to 3 minus x divided by 2. Any question?
No, sir.
All right, good, Papa. All right, so we're told now to find the composite function, f squared. And what does f squared mean?
F times itself.
F times itself, good. So f squared simply means f of x times f. And with composite function, it simply means that we are putting one function into another function. Good thing about this one is that the function that we're going to put into it is the function itself. So f times f of x is really equal to f, the function f, and we're substituting 3 minus 2x in the function. So just like how we have f of x, which is 3 minus 2x, and we find f of 1, and wherever we see x, we put 1, is the same thing. Now, instead of 1, negative 1, we have 3 minus 2x, and so we're going to introduce it wherever we see an x. So we start with the 3, then we have the minus 2, then we come upon the x. Instead of having the x, we're going to put 3 minus 2x. So there's no longer that x, but the x is now represented by 3 minus 2x. Expanding the bracket, minus 2 times 3 gives us minus 6. Minus 2 times minus 2x gives us plus 4x. And so we simplify. 3 minus 6 is minus 3. And as I said before, we can always start our answers by writing the positive number first. So we write 4x minus 3. And that would have been the composite function of f squared. Now we're told to state the value of f inverse 2. We have f inverse, but there's no f inverse 2. So f inverse from the previous question, and as I'm saying to you, look at the logics. The questions are asked in order. They are not just thrown there at any random space. So we're making use of this very same thing in the next question. So here it is. We calculated this. If we calculated this wrong, then automatically when we come over here, this is going to be automatically incorrect. So at first, what we do is to find f inverse. And we generally find the one on the outer end first. Any function that is on the outer end, we find its value first. And then we resubstitute it in the function that comes afterwards. All right. So f inverse x was 3 minus x over 2. And when we substitute minus 2, we're going to remove the x and put minus 2. This becomes 3 minus minus 2, which is the same thing as minus times minus giving me plus. So this becomes 5 over 2. And so now I know that f inverse of 2 is 5 over 2. Going again, I am now going to plug the result of f inverse 2, which is 5 over 2, into the next function, which is just simply the f function. And the f function was 3 minus 2x. So we start with the 3, subtract the 2. Now, instead of the x, what I'm going to write is 5 over 2. So that's the substitution that takes place. The 2's can cancel because it's a whole number times a fraction, and the denominator and the numerator can cancel. And so we have 3 minus 5, and 3 minus 5 gives us minus 2. All right. Simple question. It says, using a ruler, draw the lines. How many persons inside here have a 12-inch ruler and a pencil? Please ensure that you get those for your examinations. Don't blame curfew, and don't blame COVID. You must have the tools to do the right work in the exam. So it says, using a ruler, draw the lines. X is equal to a half, Y is equal to X, and X plus Y is equal to 5 on the grid below. So there's the grid, and that's where you're going to put all of those lines. But here's some information. It says X equal a half is the vertical line that cuts the X-axis at a half. So here's the X-axis, all of this line right here. Here's 1, so half would be right here. So it says it's the vertical line that cuts the X-axis at a half. So it must be a vertical line, and it must be going through a half. All right. The other one says that we have to create a table of values to draw Y is equal to X. So if Y is equal to X, if X is 0, Y is also 0. And if X is 6, Y is also 6. We can agree with that, right? Not sure? Think about it. If it says Y is equal to X, can X be 0 and Y be 2? All right, no. All right. Then the next one says that we're to create a table of values to draw X plus Y is equal to 5. So if X plus Y is equal to 5, if X is 0, Y must be 5. Because that's the only way you can get 5. And if X is 5, Y must be 0. And so what we're going to do is to plot those points on a graph. So here we have the line X is equal to a half. And we name it so that they know what the line is that we're referring to. Here we have the line Y is equal to X. If you look at any point on this line, this is 0 on the X, 0 on the Y. This is half on the X, half on the Y. 1 on the X, 1 on the Y. 1.5 on the X, 1.5 on the Y. 2 on the X, 2 on the Y. Even though we had only plotted 2 points, 0, 0, and 6, 6, the line automatically makes everything line up as Y is equal to X. This is 5, going all the way over to the line. Come down, this must also be 5. And so that's what it means when it says Y is equal to X. So we don't have to go plotting every single point. We just need to plot 2 or 3 points, and the line will take it straight through. Here again, the line X plus Y is equal to 5. So we say if X is 0, Y is 5. And if X is 5, Y is 0. If X is 1, Y must be 4. And we can see that we get Y to be 4. If X is 2, Y must be 3. If X is 3, Y must be 2. If X is 4, Y must be 1. And so plotting these 2 points and drawing a straight line through it automatically lines up every other point. Is that clear?
Yes, sir.
Yes, sir.
All right, respect. So now the question says that we're to shade or name the part that says on the grid, label as R the region where X is greater than or equal to a half, Y is greater than or equal to X, and X plus 5 is less than or equal to 5. So give me a number that is greater than a half. No, you need to talk to me now.
1.
1. Which direction do I find it? Do I find it behind this line or before this line?
Before.
Before. Very good. Now, if I want to find, give me a number that is, all right, so I need to give a range now. So if X is, which one am I at? So it's Y must be greater than or equal to X. All right, so if it is greater than or equal to X, then it can't be the values below. All right, it must be the values above. Because if X is a half, whilst Y can be equal to a half, it could also be greater than a half. That's what it says. So if X is 1, everything down here on the X-axis is going to be less than 1, don't it? So if we want a number that is greater than 1 on the Y-axis, we must go up. So 1, 2, 3, 4, 5 on the Y-axis, which is greater than 1, would be found up here. And so we shade in that direction. So we know that this comes to this direction and this goes to this direction. But this line is going to be the constrainer, because if you recognize, it changes the direction, because whilst X is greater than or equal to half, Y is greater than or equal to X, X plus Y is now less than or equal to 5. Hence, in order for me to find those values, it must be down. So all of this region out here, whilst it will go up for this line and come across for this line stops it. So this can't be part of it any at all. Are you with me? Yes or no?
Yes.
No, sir.
All right. So if I come this direction, I am satisfying here, because all the values greater than a half is on this side. We know that we shade also for this line going this direction, because we say that we're shading up. Now this line has no upward movement. It has a downward movement, so it would not satisfy all 3 of them. It only satisfies 2. It only satisfies this line and satisfies this line. So this part here could not be a part of the region that satisfies all 3 of them. Are you with me?
Yes, sir.
Yes, sir.
So I will come across here, I will go up here, but I will come down here. So the part that satisfies all 3 of them would just be this little part right here. Because again, this over here will satisfy this line. This part over here will satisfy this line, but it does not satisfy this line because this line does not come down. You get what I'm getting at? So we're looking for an area that is common to all 3 and not just some of them. Are you with me?
Yes, sir.
All right. So we're going to into some statistics now. All right, it says, using the table, determine the number of students who had exactly 13 answers. And so from the table, we can see persons who had the number of persons who had the correct answer, 13, was 11 students. The next part says that we're to find the modal number of correct answers. And the modal number of correct answers simply is the number of persons, or the highest number of persons getting a particular score. So the modal number of correct answers would have been 9. It has the highest distribution, 14. So 9 would be the modal number. The median number of correct answers. Now this is a little bit, more on the, a little bit more detail is needed here, because we have, in all of this, if we should spread out all of these information, would write 8 6 times, would write 9 14 times. So in order to find the median, we're going to have to be taking some median positions in order to be able to get the correct information. So there are 60 students, and the fact that the number is even, it means therefore that we have to take 2 middle values. We know that already. In finding median, we arrange our values from lowest to highest, and the one that is found in the middle, after shaving off from either end, becomes the median. But if it is an even number of observation, then it is going to be the 2 in the middle divided by 2. All right, good. So in this case, the total number of persons or number of students is 60. So for a set of 60 scores, the middle scores are the 30th and the 31st score. Now from the table, the 30th score is 12, and let us look at how we get it. 6 plus 14 gives us 20. So that's up to score 9, or 9, we have the 20th score. Remember I said to you that if we're supposed to write out these, we would write 8 6 times. So the 6th score will be an 8, while the 7th score will be a 9. Up to the 14th score, up to the 20th score, because we're now adding all of them together, the 20th score would still be a 9. The 21st score will be a 10. The 22nd score will still be a 10. The 23rd score will be 11. And because there are 6 of them, then the 29th score, are you with me? Will become a 12. So 6 plus 4 is 20, plus 2 gives us 22, plus 6 gives us 28. The 29th score is going to be a 12. The 30th score, because it's 2 of them, will still be a 12. So from the table, the 30th score is a 12. But we want the 30th and the 31st score. What is going to be the 31st score?
13.
13 will be the 31st score. So because we now have our 30th score and our 31st score, we need to add them together. So when we add them together, 12 plus 13 divided by 2 gives us 12.5. So what we have to find in a case like this, when we have it in a table, is to find the median position. If it was 59 scores, then we know which one would be in the middle. If it is an even number, we have to take 2 and divide it by 2. All right. So it says the probability that a student chosen at random had at least 12 correct answers. And so the probability, and P represents probability, and the statement that is given is that the student chosen at random has at least 12 correct answers, and that goes in parentheses. And that is equal to the number of students with at least 12 correct answers divided by the total number of students. And I want to go back to the data. How many students have at least, and what does that mean? Have at least 12 correct answers. Can the person have 11 correct answers to have at least 12?
No.
No. So the person must have 12 or more, which simply means then that we're going to add 2, 11, 9, and 10. So the total number of persons would have been the persons who got 12, which is 2, number of persons who got 13, which is 11, number of persons who got 14, which is 9, number of persons who got 15, which is 10. And when we sum that, we get 32 out of the total 60 students. And simplifying that, we divide 32 by 4, we get 8, and we divide 60 by 4, we get 15, and that would have been the probability in its lowest terms. So 8 out of 15 would have been the probability of the students chosen at random who would have gotten a score of at least 12 correct answers. All right, so a group of students wrote a physics examination. Each of the students achieved a grade of 1, 2, 3, or 4. The pie chart below shows the results. 39 students got a grade 3, which represents 117 degrees. And we know that the total number of degrees in the entire pie chart is supposed to be 360. So we're to determine the total number of students who wrote the examination. And so this is going to be some reasoning technique, all right? So if 117 degree represents 39 students, then going back to what we did earlier with the question of the Mexican versus the ECD dollars and finding what $1 is, we basically use about the same principle to find what 1 degree is. 1 degree will represent 39 divided by 117. So the number of students who wrote the examination is represented by the whole pie chart, or an angle of 360 degrees. Therefore, the number of students who wrote the examination would have been 39 over 117, which represents 1 degree times 360. And so we get 120 students. All right. Good. It says the ratio of the number of students who achieved a grade 1 to a grade 2 or 4 is 2 to 4 to 3, a student passed the examination if he or she achieved a grade 1, 2, or 3. How many students passed the examination? And this now takes into a lot of critical thinking. So if the ratio of number of students who achieve grade 1, 2, and 4 is 2 to 4 to 3, then the number of students who receive a grade 3 is 39. The number of students who achieve the other grades would have been 81. So the ratio that we have is really referring to 81 students and not the whole 120 students. Because the information speaks to just those, the ratio speaks to just those who get grades 1, 2, and 4. We already know how many students receive grade 3. So the number of students who attain grade 1 would have been 2 portions out of the total ratio, which is 2 plus 4 plus 3. All right? And that would have been 2 out of 9. And 9 into 81 goes 9 times, and 2 times 9 gives us 18 students. So 18 students got grade 1. The total number of students who attained grade 2 would have been 4 portions, again, out of the total 9. 9 into 81 goes 9, 4 nines gives us 36. Now, it is only helpful to work out what the number of students who get grade 4. But you don't have to do that, because what the question really asks you is how many students pass the examination. So you only want to know those who get a grade 1, a grade 2, or a grade 3. So truthfully, even though I worked it out, it is not essential, but you may want to work it out to see if you would have gotten back the full 81, so that you can have an idea as to whether you are right or incorrect. So the number of students who pass is the number of students who receive grade 1, 2, or 3. Only grade 1 and 2 we needed to calculate because grade 3 was already calculated. And so 18 plus 36 plus 39 is equal to 93. So 93 of the 100 students passed the examination. It says determine the value of the angle for the sector representing grade 1 in the pie chart. And so the number of students who attain grade 1 is 18, and the angle of the sector representing grade 1 would be 18 out of the 120 students times the 360. And that would have been 54 degrees. You can probably try and work out for the other ones, even though it didn't ask you. So how do we find the angle of a sector? The portion out of the total times 360, because 360 represents the total amount of degrees in a circle. All right. Any question?
Sir, which year paper is this?
January 2021.
Okay, thank you.
No problem. So it says in this question, take pi to be 22/7. The diagram below shows a rectangular tank with base 50 centimeter by 40 centimeter that is used to store water. The tank is filled with water to a depth of 15 centimeter. Calculate the volume of the tank, and we know that the volume of a cuboid is length times width times height, where the length and width comes from the cross section or the base of the shape in some cases. and the height is in this case, would have been the depth to which the water is. So we have 40 times 50 times 15. And that is measured in cubic centimeter because we're looking at volume, and we get 30,000 cubic centimeter. It says a cylindrical container shown in the diagram below is used to fetch more water to fill the rectangular tank. The container, which is completely filled with water, has a radius of 20 centimeter and a height of 21 centimeter. All the water in this container is added to the water in the rectangular tank, and we're to calculate the total volume of water that is now in the rectangular tank. Now, the volume of a cylinder is given by pi r square times height. Again, remember, we're told what to use pi as, and so we can't choose how we want to work with pi. We must use pi as the information that is provided. So we know that pi is 22/7. We know that the radius is 20, and we know that the height is 21. So we find the volume, which is 22/7 times 20 square, because it's radius square, times 21, and that is going to be cubic centimeter. And that gives us 26,400 cubic centimeter. Now the question says that all the water in this container is added to the water in the rectangular tank. So we have to calculate the total volume of water in the rectangular tank. So if we stopped it at 26,400, then we would only be answering information that is unnecessary about the cylindrical tank. The cylindrical tank really is only giving us additional information to complete the question for the rectangular tank. So now we need to combine both to know how much water can be accommodated in both tanks. So the water that is already inside there, 30,000, plus the water that is now going to go in there from the tank, 26,400, total gives us 56,400 cubic centimeter. It says that we're to show that the new depth of water in the rectangular tank is 58.2 centimeter. So it is no longer 15, but 28.2, sorry. So again, all we simply need to do, using back our information, the volume of the water in the tank altogether is 56,400. And we use H to represent the new depth of the height of the water. And because it's a cuboid, it still remains length times width times height. We already know the length and the width to be 40 times 50. Now we don't know the height in this case. So again, we have been transposing formulas throughout to find different things. And so we are going to continuously use that approach throughout the question. So we want H by itself. So we move 50 times 40. They were being multiplied. They're connected to H by multiplication. So we divide in this case. We could simply say 50 times 40 and divide by the answer, but it's the same thing as having not yet worked it out. It still remains 40 times 50. And so when we divide through, we get 28.2. And so the height actually is 28.2. Again, I want you to recognize, students, this is how CXC have been asking their questions. There's logics to everything. It's mathematics. It's not confusing. We just probably need to look at the processes. Now, they gave you the answer to the depth. All you have to do is to work to get 28.2 So if you're not getting 28.2, then something is either wrong, or it will tell you to prove whether or not it is correct. If it says prove whether or not it is correct, then you have the option to choose. If your answer is not proving it, then hoping that you are correct, or if it is proving it, then. All right, but in this case, it just show that it is, which means therefore that that's the answer it is supposed to be. It says the vertical height of the rectangular tank is 48 centimeter. Determine how many more cylindrical containers of water must be poured into the rectangular tank for it to be completely filled. So the volume of the rectangular tank with the new height gives us 96,000 cubic centimeter. And the volume of water already in the tank is 56,400. So the additional volume that is needed is 39,600. Therefore, if we divide 39,600 by 26,400, we will get 1.5 containers of water. Are you with me? So technically, 2 filled cylindrical containers will be more than sufficient to fill the tank. Since as we want it to be completely filled, so we want at least two more to sufficiently complete the tank. We know that 1.5 container, but we're not going to go fetch now half a container. We're going to fetch the full container and pour and leave back. So 2 full containers will be able to sufficiently give us the new volume. All right. I think this may look like 15. It is not 15. It is actually 1.5. Any question? All right. So here is the question that you are supposed to get full marks on in the examination, albeit this question requires you to use your thinking. It's a sequence question. It's an investigation question. This question comes every single year in different form, shape, and format, but it requires you to use your problem-solving skills. Now, figure 1, figure 2, figure 3, figure 4 are all connected. And you can see the differences in all of the figures as they go along. So what is required is that you look at it and figure out what is it that is happening. All right. Now here's a table that you're asked to complete. Now, what do you notice is happening in the column that says dots? By just your own imagination, what do you recognize is happening?
Sir, you're counting by 4?
All right, so I'm counting
Or
by
you're
4.
adding 4 each.
Increasing, all right, so good.
Yes.
I'm increasing by 4, very good. All right. Now, what do you recognize is happening in the area of the outer largest square? What kind of numbers are these?
Square numbers, sir?
So they are square numbers. Very good.
Oh,
Is there anywhere in the diagram that I can look to see what is it that could give me 4 having squared it, or 9 having squared it, or 16 having squared it, or 25 having squared it? Is there anywhere in the table that I could look at to say, okay, fine, this possibly could seem to be something that I look at?
Figure number.
The figure number. All right, so we're getting somewhere. Good. What about the area of the shaded region? Is there anything that we could look at? What do we recognize that is happening with the shaded region? Anything jumps to mind? Anything comes to mind? Anything that we can mix and match up? Anything that we can rig up?
sir, it's the first I'm seeing this table look so hard with so much
not
columns
hard.
and something there.
It's not hard, man. It's not hard. Trust me. Think about it. All right, so let us look at them. All right. So the number of dots, which is D, we're going to call it, is 4 times n plus a constant. All right. Because we recognize that they are increasing consistently by the number 4. So when n is 1, D is equal to 5, because 4 times 1 gives us 4, and then the constant to give us 5 has to be 1. Hence, C is going to be 1. And in this case, we add the 1 and not subtract the 1. So we automatically know now that the pattern is given by 4n plus 1. So instead of just going ahead and say, oh, we're going to add 4 to 17, let us try and see what 4n plus 1 is. 4 times 5 gives us 20, plus 1 gives us 21. Good. So we know that 5 plus 0 times 4 gives us 5. 5 plus 1 times 4 gives us 9. 5 plus 2 times 4 gives us 13. And so another way that we could actually look at it is to use n minus 1. So in this case, we could be adding 5 as well, but then it changes how it is that we look at what happens with the 4. So in this case, we're adding 1, and we're just simply multiplying the 4 by the figure number. We could also say we're adding 5, and so we manipulate the figure number. In order for me to get back 5 here, everything that is being multiplied with 4 has to be 0. In order to get 9 here, adding 5, it must be 4 times 1. How do I get 2 to become 1? It has to be this number minus 1. And so that's a different explanation. Now, no 2 persons will necessarily come up with the same sort of thinking in the examination, because as I said before, it's an investigation. It is how you see it and can prove it. So here are 2 different ways that this one column could have been identified. N is 4n plus 1, but it could also be written as 5 plus n minus 1 times 4, which technically gives us back the same thing, 4n plus 1. So it depends on how you look at it. All right. So we know that this is 21, and we know that this is 4n minus 1. All right, so for column 3, as we said before, they were square numbers. And so we know that to find the area of a circle, it is pi times the radius square. And so in this case, we had already established that to be n squared times pi. Just going back to it. Here we're talking. So where we get 25 square, this would have been n squared times pi. Pi remains constant. The only thing that changes is the coefficient, which comes from the square of the figure. So now let us look at the fourth column. So the fourth column, we have 2 times the figure n minus 1 times pi. So if we test when n is equal to 1, 1, 3, and 4, we would see that the formula holds true. So we're going to go back again to prove that 2n minus 1 times pi is actually correct. So 2 times 1 gives us 2, minus 1 gives us 1, times pi simply gives us pi. 2 times 2 gives us 4, minus 1 gives us 3, times pi holds true. 2 times 3, 6, minus 1, 5, times pi holds true. 2 times 4, 8, times minus 1, times pi gives us 7 pi holds true. 2 times 5, 10, minus 1, times pi will give us 9 pi. And for n, it will be 2n minus 1 times pi. Another way that we could look at it, again, we could subtract 1 from n, still multiply by, we end up, in any case, getting back the same thing, but it's just the process that the person would go through. For column 5, the total length of the circumference of the circle, 2 pi, 6 pi, 12 pi, 20 pi. We would recognize that the total length of all the circumferences of all the circle is 1 more than the number of the figure, which becomes n plus 1, then times the figure number, and then times pi. So 1 plus 1, 2, 2 times 1 times pi, 2 pi. 2 plus 1, 3, 3 times 2 times pi, 6. 3 plus 1, 3, sorry, 3 plus 1, 4 times 3 gives us 12 times pi gives us 12 pi. So when it is the fifth one, it is going to be 5 plus 1, which is going to be 6. 6 fives gives us 30, and then we get 30 pi. And for the nth figure, we establish it is n plus 1 times n, then times pi. And so in completing the table, this is what the table would look like. For n plus 1, n squared times pi, to n minus 1 times pi, and n times n plus 1 pi. I want you to understand that this part of the table right here with all of these exclamation marks simply means that you must not do anything there. One other thing that I want to point out to you as you look at questions like these, bear in mind your figure number. Look at it carefully because this could be 4 and then they jump right here to 11. It does not mean that it must be the next number that comes. That is most times a trick in the examination. And because persons see 1, 2, 3, 4, they don't look and they just automatically fill in the information for the next section, which is not necessarily the number that comes immediately after. So that's something that you need to look out for in the examination. And so it says determine the value of n when the number of dots in the figure is 541. And simply it's just an equation. We already know that the number of dots is equal to 4n plus 1. So 541 is equal to 4n plus 1. And we just simply solve to find n. So we leave n by itself. So we move 1 first. So we have 540 is equal to 4n. Therefore, n is equal to 540 divided by 4. So the 135th figure is going to have 541 dots. And that is why we have to establish the pattern from early, because we could never have counted down to the 135th shape until we get 541. It says write down in terms of P and pi the area of the largest circle in figure 3P. So figure 3P, the area of the largest circle, we know that it is n squared pi. So all we simply need to do in figure 3P, n is equal to 3P. So the area of the largest circle is n squared pi. And we know that n is 3P. So it is going to be 3P squared times pi. And once the square is outside the bracket, everything on the inside of the bracket is to be squared. So 3 squared is 9 and p squared is p squared times pi. And that would have been the shape. All right. The straight line graph of x is equal to 5 minus 3y intersects the x-axis at P and the y-axis coordinates of P and Q. So if the line cuts the x-axis at y equals 0, substituting 0 for y, x therefore becomes 5 minus 3 times 0, which automatically becomes 5. Therefore, the coordinates at P would be x being 5 and y being 0. We establish it at first. A line cuts the x-axis at y is equal to 0, substituting the value for y as 0 into the function, we get x is equal to 5 minus 3 times 0. So 5 minus 3 times 0, which is the same thing as 5 minus 0, gives us 5. And writing it as coordinates, 5, 0. And also, a line cuts the y-axis at x is equal to 0. Now that we know that x is equal to 5 minus 3y, then 0 is equal to 5 minus 3y. And so we flip it by making the 3y positive. So we have 3y is equal to 5. Therefore, y is equal to 5 over 3 if we're going to solve to make y the subject. Therefore, Q as coordinates, the point Q is 0, 5 over 3. It says calculate the length of PQ, giving your answer to 2 decimal places. So basically, what we're going to be doing is to take each point, and so we're going to be using Pythagoras' theorem. So the length of PQ is equal to the first point square. All right, so here we have the x's. So 0 minus 5 which would have been the x points from both points, the point P and point Q, and we square them, and then the y values from both points, 5, 3, minus 0. So we take the two x values and subtract them, the two y values and subtract them, and then we square them. So 0 minus 5 is 5, and the square of any number is a positive result. So this is 25. 5 over 3 minus 0 is still 5 over 3. Squaring both numbers on the inside, 5 squared gives us 25, 3 squared gives us 9. And so here we have 25 over 9 can be written as 2 and 7 over 9. So we automatically have 25 plus 2, which gives us 27 over 9. And then this gives us 250 over 9. Can anybody tell me how I get 250 over 9? Can anybody tell me how? I get 250 over 9? Come on, man. Nobody? So 9 times 27 plus 27 gives us 250 over 9, coming from our previous example of using fractions. All right, so we can simply take the square root of each number separately. So the square root of 9 is 3, the square root of 250 having divided by 3 gives us 5.270, and we approximate that to 5.27 units, correct to 2 decimal places. All right, so I am going to ask you, now that we have point P and Q, I'm going to give you just about 2 minutes to see if you can come up with the midpoint of PQ. Work on that for yourself, and then we come back in 2 minutes for your discussion. So just want you to work out the midpoint and just listen to what the word says, midpoint of PQ. All right, so that was the longest 2 minutes I have ever come across. So I'm pretty much sure that you should all be able to give me the answer. What is the midpoint of the coordinates?
Um, 5/2 and 5/6 is what I got.
5/2 and
5/6.
5/2 and 5/6. All right, anybody else? Remember, now we're not about right or wrong. We're building our competence. Anybody else? All right, so thank you for the bravery and the try, Lenny. Let us see what it is that I have. So yes, your 5/2 and your 5/6 were indeed correct. All right, because 2.5 still is 5/2 and 5/6. So basically we take the x coordinates, add them together, divided by 2, take the y coordinates, add them together and divide by 2. So 0 plus 5 is 5/2, give us 5.5, and 5/3 plus 0 is 5/6. All right, very good. Can see the grade ones, man. All right, so the functions f and g are defined as follows. F of x is 5 minus x, and g of x is x squared minus 2x minus 1. The graphs of fx and gx meets at points m and m. Determine the coordinates of the points m and n. So basically, this is a collision of two, a linear and a quadratic curve. And so we're going to basically use simultaneous equations. When we have a linear and a quadratic coming together, we actually solve as a simultaneous equation. So f of x is 5 minus x, and we got that from the information. G of x is x squared minus 2x minus 1. We got that as well from the information. Now, we don't want to work with f and g because we want to use an identifier to make them common. So we change the f of x and g of x, because really and truly what they're actually saying is that they are y. So let y is equal to 5 minus x, that's equation 1, and y is equal to x squared minus 2x minus 1 as equation 2. And to solve them simultaneously to find m and n, all we simply need to do is to substitute equation 1 into 2. So where we have y, we know that that is equal to 5 minus x. So we just simply substitute it. So right here where we have y, we are going to put 5 minus x. And so that becomes 5 minus x is equal to x squared minus 2x minus 1. Combining like terms, so we end up with x squared minus 2x plus 1 plus x because it comes to the other side of the equation, and minus 5 because it comes to the other side of the equation, and that is equal to 0. Simplifying, x squared minus x minus 6 is equal to 0. And so we solve simultaneously by identifying the pairs of brackets that would give us back this result. So this one was simple and easy because we know that we just need to open two brackets. X times x gives us x squared. 2 times x times, are you with me? I want to go too fast. Are you with me? Talk to me, man.
Yes, sir.
Yes, sir.
Okay. All right. So we have x times x. That gives us x squared. We have negative 3 times 2, that gives us negative 6. But we have x times 2, that gives us 2x, and negative 3 times x, that gives us negative 3x. When we combine 2x and negative 3x, we get negative x. And so we know that this pair of factors actually represents this equation. So we need to solve now for x. So in this case, x minus 3 is equal to 0, therefore x is equal to 3. And x plus 2 is equal to 0, therefore x is equal to negative 2. Now we have identified what the x values are for the 2 points. Now we need to find what the y values are by substituting those x values into the equation. So y is equal to 5 minus x, and since x is equal to 3, y is equal to 5 minus 3, therefore y is equal to 2. Y again is equal to 5 minus x. When x is equal to negative 2, 5 minus minus 2 gives us 7. So we may say m is equal to 3, 2, and n is equal to minus 2, 7. It wouldn't hurt to say either one of them because the question did not tell us. We are now assuming which point is which. We only know that the coordinates are when x is equal to 3, the y value is equal to 2. That is a pair. We can't put it with anything else because those are the two values that gave us that. But we can name it m. When we use negative 2, we got 7. We have to put them together and we can name that n. All right. Now Monty is cycling at 12 meters per second. After 4.5 seconds, he starts to decelerate, and after further 2.5 seconds, he stops. The speed time graph is shown below. We're to identify the constant deceleration. And so the constant deceleration is the gradient of the speed using the line of deceleration. So when they get to this point right here, it starts to come down to this point. And so right here, we are at 12. All right. And we are not moving. So we can simply, if we want to form a right angle triangle, we can. So here we have 12, and we're not going anywhere else. So we're just right there. And so we come from 4.5 to 7 on the x. So right here is 4, right here is 4.5, here's 5. So the gradient of the speed would be 12 minus 0. That's the only point on the y-axis, so to speak, the highest point there. And 4.5 minus 7. So 12 divided by 2.5 is equal to 4.8. And so the deceleration would have been positive 4.8 meters per second, since as what we actually looked at for the gradient is really the acceleration. All right, so we move from 0 to 12. We move from 0 to 12. So that would help us to identify the acceleration that takes place, the change in y. So the change in y means that I move from 0 speed to 12 speed. All right. So 0 miles per second to 12 miles per second. And so that gives me my acceleration. But the question asks me for deceleration. Everybody's with me? So Monty's average speed. All right, so Monty's average speed over the 7 seconds. We're asked to find that. So Monty's average speed really comes to us from quite a number of information. So we need the area under the graph, which is actually a trapezium. So the top part and the area of a trapezium is given by half of the sum of the parallel sides, which would have been the top part and the bottom part. And so from here to here is 4.5. We've established that. And from here to here is 7. So 4.5 plus 7 would have been 4.5 would be the length of the top, and 7 would be the length of the bottom. And we multiply it now by the perpendicular height, which is from 0 to 12. So that would be 12. So half of 4.5 plus 7 times 12 gives us 69 meters. Now the average speed would be the distance covered by the time taken. So since the average speed is 69 and the distance and the time taken is 7 seconds, then we get 9.86 meters per second, correct to 3 significant figures.
Sir, is it always a trapezium in this with the speed graph?
Most times it is. It may not necessarily come to you as if it is a speed graph, but it technically, because you're looking for the area underneath the graph, then you're going to get it. So there's 2 different one in this question. You're looking at a speed graph. You could also be looking at a velocity graph, which is a different graph. But this one is a time speed graph, which is going to reflect a trapezium. The other one could be a velocity graph, which looks at something different.
Okay.
All righty. All right, so we have just about 2 more questions to complete today. So I would love if we don't get to end by 12:30, that we go to at least 1 o'clock, an extra half an hour, so that we can just complete this. I'm going to send you a link as well for a WhatsApp group that we would love to continue to have some discussion on. If you are working any question and you probably come into a challenge, that you can share your thoughts in the group, and I will be able to more than happy to assist you as you prepare for your examinations. So we are at the 9th question on the examination paper 2021 January paper 2, and we get to something that I find very interesting, because most times we lose our confidence when we look at all of these diagrams embedded in a whole ton load of spaces, without even really and truly look at the details provided to us. All right, but I'm going to give you just probably about 5 minutes to refresh yourself. And then I will be back with you. All right. All right, so this may have been your shortest 5 minutes. All right. My mind clock seems not to be working. When I give a short time, I take longer. When I give a long time, I take short. I mean, boy, age will catch up on me. All right. So it says in the diagram below, A, B, C, and D are points on the circumference of a circle with center O, and AOC and BOD are diameters of the circle. AB and DC are parallel. It says state the reason why angle ABC is 90 degrees. So already it tells you what the answer is. What it wants is for you to give them the theorem or the principle as to why this answer, 90 degrees, is accurate. If you're still with me, just raise your hand so I can know that you're here. You don't have to talk this time. Okay.
Yes, sir.
All right. All right. All right. Good. So it says if O is the center of the circle, hence the line AOC is a diameter. And a diameter subtends a right angle on the circumference of a circle. So here being AOC, any angle from the diameter subtending on the circumference is a right angle. Or we can simply say angle in a semicircle is 90 degrees. Since B is on the circumference of the circle subtended by the diameter, ABC is 90 degrees. It's just the reason that they want you to give. We already know that it is 90 degrees, but you must know why it is 90 degrees. So any angle subtended at the circumference coming from a diameter is 90 degrees. Is there any other angle that you can look at in the diagram that you think, based on the information provided to you, that would be a 90-degree angle?
No, sir, because as me look, me only this the right angle. Me never see nothing else.
All right. How many diameters are in the diagram?
2.
2. Are there how many angles are formed at the circumference from the diameters?
4.
All right, so 4. All right, good. But let us use letters now. So we have two triangles, triangle ABC and triangle BCD. We established that angle B is 90 degrees because it comes from the diameter AC. Is there any other angle that can?
C.
So angle C would also be 90 degrees because it too comes from a diameter, which is BD. All right. So we're asked to find angle BAC, which is angle A. So here, angle BAC. So we know that this is 90. We know that this is 2P. We know that this is 3P. So we're going to have to basically do some algebra here to figure out what angle BAC is. We know that the sum of angles in a triangle is 180 degrees, and already one of the angle is 90. 2P and 3P would have been the only two unknown angles in the triangle. And so we can solve for P to help us to identify what the value of angle A is. So 2P plus 3P gives us 5P, and solving for P, we get P to be 18. Hence, angle BAC, which is 2P, is 2 times 18, which gives us 36. Now we're asked to find angle Q. I'm going to go back to the diagram again. And so angle Q is right here. Now, there's another theorem that we're going to establish now in order to be able to find angle Q. Now, BDC and BAC, which is angle A and angle Q, or angle 2P. Let's look at it again. So angle A and angle D, which would have been 2P and Q, they are equal. They are equal because of the fact that angles subtended by a chord, and I'll show you just what it means in a while, at the circumference of a circle and standing on the same arc are equal. A whole lot to digest, but let us probably look at it. So here is the chord BC. Now, any angle that is formed from this chord touching the circumference and they are on the same arc. So if you recognize, DA is an arc. If the two angles touch the same arc, then they are equal. So we just calculated 2P to be 36. Therefore, Q is also going to be 36. Reason being, angles subtended from a chord touching the circumference at the same arc are equal. Or to calculate the value of angle R, I want us to look back at angle R where it is at. So angle R is right here. Now, somebody said earlier that all of this angle right here is 90. Do we have any information about angle 3P, or can we calculate angle 3P?
Sir, you have 3P, sir.
All right, so we don't have 3P, but we have information about P that can help us to, we had only calculated 2P. So 3P would have still be 3 times 18. And because we know that everything here has to be 90, then we can know what angle R is. Very good. So BCD, which is angle C, is equal to 90, angle in a semicircle. So R plus 3P must be equal to 90. So R plus 3 times 18 is equal to 90. R therefore is 90 minus 54, which is 36. So we've established that. Or AB is parallel to DC and AC is a transversal. Coming from a question that we looked at earlier in the lesson with the pentagon. It says BAC is equal to ACD, which are alternate. And so let us look at that. So we looked at co-interior angles being angles that are formed within the C. Some people call it the F, and that's fine. Now, this angle right here, 2P, is the same thing as R because they are alternate. They are formed within alternate positions of what we call the Z. I'm pretty much sure you've heard Z angles. So here is the parallel lines. AC is a transversal. So the angle that is formed right here, 2P, which we know to be 36, is the same thing as R, which is 36. So there are two ways that we could calculate R. But basically what we have to do is to use the information that we have, the theorems that we know, to be able to guide us into answering the questions. Importantly, this question is almost like a, you know, a mind game. You're unlocking one level to get to the next level. All right. So that was two ways that we could find. All right. So from a harbor, H, the bearing of two bays, S and Q, are 185 and 311 respectively. Q is 5.4 kilometer from H, while S is 3.5 kilometer from H. It says on the diagram below, which shows the sketch of this information, insert the value of the marked angle QHS. So QHS basically is this angle right here. We know that from the bearing of H to S is 185, and the bearing of H to the Q is 311. So if from this north line, because every position of movement in a bearing must start at a north line. So if we're starting at H and we're going to S, we go 185, and then this line breaks the angle. So from the north line to this line right here is 185. But we also know that from this line all the way up to the line Q is 311. How can we find this part right here, which only represents QHS?
Subtract, sir.
All right, so subtract. What would we subtract?
The 185 from the 311.
The 185 from the 311. Very good. All right. So we get 126, because we know that from the north line all the way up to Q should be 311. But from the north line to S is only 185. So the difference must be QHS. So we get 311 minus 185, which is equal to 126. It says that we're to calculate QS, which is a distance between the two bays. And so here we have angle QHS being 126. We know that QH is 5.4, and we know that HS is 3.5. And so because we're not dealing with a right angle triangle, we have to use what is called the sine or the cosine rule. In this case, we are using the cosine rule because of the fact that we have two sides, QH and HS, and we have the angle in between, which is 126. The other reason that if we were to use the cosine rule in any other case, it would have meant therefore that we have all three sides. All right, so we use all three sides for the cosine rule, or we use two sides and the angle between the two sides. So what that simply means is that we're finding the opposite side of the angle, which is QS. So QS square is equal to the square of 5.4, which is one leg, plus 3.5 square, which is the next leg, minus 2 times the product of the very same side. So we square the sides and add them, and then we multiply the sides by 2. And then we find the cosine of the angle which is opposite to the side that we're finding. All right. So 5.4 square plus 3.5 square gives us 29.16 plus 12.25. And we're subtracting. And what I want you to note is that we are always going to be subtracting all of this part right here. So we're subtracting 2 times 5.4 times 3.5 times the cosine of 126. And we get negative 22.218. So from multiplying 2 times 5.4 times 3.5 times the cosine of 126, we get negative 22.218. Then we now subtract that from the information that we had before. And that gives us 63.628. But all of that represents the square of QS. But that's not what the question asks us to find. The question asks us to find QS. So what we're going to do now is to take the square root of 63.628 to find QS, and we get 7.977, or approximately 7.98 kilometer, correct to 2 decimal places. Note that every single time I do an approximation, I put the information that represents the approximation in the question. All right. The question says that I'm to calculate the bearing of S from Q. So basically, the bearing of S from Q simply means that the north line, so I want all of from this part come around. All right, so as I said, north line is at Q. North line is at Q. And so I want all the parts that's coming around. So from Q all the way to the line S, the line that QS is at. I can't stop at here. I can't stop on because this is the H line. So that would have been the bearing of H from Q. I want the bearing of S from Q. So all of this part right here. So importantly, I don't have the full angle, so I know a part. I just calculated this to be 7.97. I calculated this to be 3.5, and I calculated this to be 5.4. All right. Now I know that all of this angle right here is 186. But I also know from the information given that from here to here is co-interior to here. So I'll get into that a little. All right, so this time I'm going to be using the cosine rule, sorry, the sine rule, which is 3.5 over sine theta, which represents the angle that I don't know. So 3.5 represents the side that I know, and theta represents the angle that I don't know. Now I need to find a full pair of a side and an opposite angle. So I knew that this was 126, and I know that this is 7.97. So I use that. So in order for me to find the sine theta is going to be 3.5 times sine 126 divided by 7.977. And that gives me 0.3550. And because I want theta and not sine theta, I find the inverse of sine, 0.3550, and I get 20.79. And so the angle in the little part right here is 20.79. Therefore, the bearing of S from Q, starting at the north line, comes from the north to this east. And if you recognize, east is a complete 90 degrees, hence we get the 90 degrees here. All right. So we have to do some calculations. We know that from this north line to this point right here would be 90 degrees. We also know that from this line right here to this line is another 90 degrees. So that's 180. So if from here to here is 185, it means therefore that this little part right here is 5 degrees. Are you with me?
Yes, sir.
Good. So that's how we're going to get the 185, because from north to south is 180. But from the north to the line is 185. Therefore, this little part has to be 85. We also know that from south to west is also 90. So if this is 5, all of right here is going to be 85 to give me 90. Are you with me? I need some talk back now.
No, sir.
So from this straight line, which is due west, coming south is 90 degrees. So remember, so from north to east is going to be 90. From east to south is going to be 90. That gives us 180. From south to west is going to be 90. And then from west to north is going to be 90. That's how we're going to get the 360.
Yes.
So this angle right here, which is 126, if you recognize, it is split in two. Do we see the line coming through that splits it in two? This line right
Yes, sir.
Good. So from right here all the way back down to this south line is 90 degrees. We established that part of it is already 5. So to complete the 90 degree for just this part is going to be this little part right here being 85. Are you with me?
Yes, sir.
Good. Now, if this part alone is 85 and the entire angle inside here is going to be 126, then this little part right here is going to be the difference of 126 and 85, which is going to be 41. And so if you come back to the diagram that I have around here, you will see how I have the 5 degree, the 85, and the 41 right here. Do we see that?
Yes, sir.
Good. Now, this angle right here we established to be 90 degrees. But we also know that this Z angle right here makes these two angles right here equal. So now that I know that this is 41, I can also know that this is 41 as well. So I have already 90 plus 41. And the last angle that I just calculated, which is the part on the inside, which is 20.79, gives us 151.79. And then that added together gives me 152, which is correct to the nearest degree. So basically, what we have been doing is to unlock different portions of the maze. probably it's Minecraft. So we're unlocking different portions to be able to get the information that we have. So if you recognize, we have been using basically the same information, the alternate angle. We have been using it quite throughout the paper, not just in one question. Because the truth is, math has an interconnectedness that once we know the basic principles, straight throughout mathematics we'll be using them. We have been answering about 3 to 4 questions so far using all of the principles of geometry, all the principles of angles, without even knowing that that's what we're doing. And so that's how we are to learn math, to see the connectedness so that we will be able to make the right decisions as to what information to use. Are we good? And so we are at the final question. And I hope and trust that we will last through the time. And so far, I hope and trust that you would have learned something or reinforced something, and this session would have been at least beneficial to you. So given that matrix W is equal to 3, 6, negative 2, 5, we're to determine the 2 by 2 matrix L such that W plus L is equal to the null matrix. So if W is equal to 3, 6, negative 2, and 5, and adding L to a matrix gives us the null matrix, let us make L A, B, C, D. So L plus W is supposed to give us 0. So taking corresponding values, 3 plus A gives me 3A, 6 plus B give me 6B, minus 2 plus C give me minus 2 plus C, and 5 plus D gives me 5 plus D, and all of that is equal to 0. I may have missed my equal sign, but forgive me. So this should have a little equal sign coming through. So equating corresponding entries, 3 plus A is equal to 0. Therefore, A is equal to negative 3. 6 plus B is equal to 0. Therefore, B is equal to negative 6. Negative 2 plus C is equal to 0. Therefore, C is equal to 2. 5 plus D is equal to 0. Therefore, D is equal to negative 5. And so L then is simply putting the values that we get in their respective place. So A is replaced with negative 3, B is replaced with negative 6, C is replaced with 2, and D is replaced with negative 5. And that would have been the 2 by 2 matrix that gives us the null matrix. So if I add 3 plus negative 3 is the same thing as 3 minus 3, and that really gives me 0. 6 minus 6 does give me 0. Minus 2 plus 2 does give me 0. And 5 minus 5 does give me 0. So I know that my values are correct. So it says we're now to find the 2 by 2 matrix P such that W times P is equal to the identity matrix. Now, I can tell you from now that the identity matrix is formed when it is that we multiply a matrix by its inverse. So if we multiply W by its inverse, we're going to get the identity matrix. So P in this case is the inverse of W. So if WP is equal to 1001, hence P must be W, or the inverse of W, since W times its inverse is equal to the identity matrix. So we're going to find W inverse as P. Now the determinant of W is simply the elements in the leading diagonal, which is 3 times 5, subtracting the product or the product of the elements in the leading diagonal, 3 times 5, minus the product in the non-leading diagonal, which is negative 2 times 6. So 3 times 5 is 15, and 6 times negative 2 is negative 12, times negative 1 gives me positive 12. And so 12 plus 15 gives me 27. So that's the determinant. Now the determinant is given by, or the inverse rather is given by 1 upon the determinant, and we interchange the elements in the leading diagonal. So we started out by having 3, now we have 5. And we change the sign of the non-leading diagonal. So where we had positive 6, we now have negative 6. Where we have negative 2, we now have positive 2. And where we ended with 5, we now end with 3. And so all we simply need to do is to multiply each element on the inside by the determinant. So 1 upon 27 times 5 gives us 5 over 27. 1 over 27 times negative 6 gives us negative 6 over 27. 1 upon 27 over times 2 gives us 2 over 27. And 1 upon 27 times 3 gives us 3 upon 27. And we can simplify that. 5 over 27 remains, there's nothing common. 3 can go into 6 rather, 2 times, and into 27, 9, we're left with negative 2 over 9. And 2 over 27 can be written as just the same, can't change, nothing common. And 3 into itself 1, and into 27, 1 over 9. And so we would simply just finish writing that P then is equal to 5 over 27 negative 2 over 9, 2 over 27, and 1 over 9. Since as a question asks us to find P, so whilst we know that P is the inverse of W, it did say that we're to find the 2 by 2 matrix called P. And so in the final analysis, even though we know that is the inverse of W, we must write it as P. Is that clear? So it says a right angled triangle M has vertices x, 1, 1, y, 3, 1, and z, 3, 4 when M is transformed by the matrix N equals 0, 1, 1, 0. The image is M prime. We're to find the coordinates of the vertices of M prime. And so we're going to work this through. So we set up a matrix for the coordinates, and so we call it T. And so for X, we get 1, 1, Y, we get 3, 1, Z, we get 3, 4. Now we know that if we multiply N by T, we are supposed to get M prime. Hence, 0, 1, 1, 0, which is a 2 by 2 matrix, and the matrix that we call T can be multiplied because of the fact that these two numbers, the column of this matrix, which is 2, and the row of this matrix, which is 2, are equal. So because they are equal, they can be multiplied. And we know that the result is going to be a 2 by 2 matrix. So the n values tells us which matrix we will get. So the order of this matrix is a 2 by 2. The order of this matrix is a 2 by 3. And they can be multiplied because the number of columns in the first matrix is the same as the number of rows in the second matrix. And therefore, the results would be a 2 by 3 matrix, which is the end values. All right. So each element is going to be element 1 of the first row and first column, element 1 of the first row but second column, element 1 of the first row but the third column, and the numbering continues. This will be element of the second row but the first column, element of the second row but the second column, element of the second row but the third column. So these are going to be my results. So basically all I simply need to do is to multiply. And how do we multiply? Row by column. So to get E11, it is 0 times 1 plus 1 times 1. And when we simplify that, 0 times 1 is 0, plus 1 times 1 gives us 1. For E12, it is going to be 0 times 3 row times column, 1 times 1. 0 times 3 is 0, 1 times 1 is 1. For E13, 0 times 3 row times column, 1 times 4. 0 times 3 is 0, 1 times 4 is 4. Going now to the second row. So we have 1 times 1 row times column plus 0 times 1. Are we following?
Yes, sir. Yes, sir.
Okay. 1 times 3, and then 0 times 1. 1 times 3, then 0 times 4. And so we take the answers now and put them in their respective position. So 1 comes as the first element in the first column for the first row, I will write them according to their positions in the matrix. And that would have been the coordinates of the vertices. All right, we're not finished with this question yet, so let me write the coordinates because we have not yet written the coordinates. All right, so if you leave your answer like this, you will not have answered the question because it says coordinates. So let us say x prime would have been 1, comma 1. Y prime would have been 1, comma 3. And z prime would have been equal to 4, comma 3. So those would have been the coordinates. You must write coordinates this way. And since that's what the question asked you for, that is what is required.
Sir, me kind of lost. So where coordinate them come from?
The same, so here, so look, just remember, look at how they had given us the coordinates for x. They give us the coordinates for x as 1, 1, y as 3, 1, and z as 3, 4. But because I have this in this arrangement, I could not keep them like that. That's how I ended up having to create a T matrix. So if you look, the 1, 1 became 1, 1. The y became 3, 1. The z became 3, 4. These are not coordinates. This is a matrix. So when I'm finished answering my question, I end up with a matrix, but they didn't ask us for the matrix. They said find the coordinates of the vertices of M prime. And the coordinates of So the vertices of M prime is X prime, Y prime, Z prime. So they want the coordinates of those points.
Okay.
So I have to take them back from the matrix, write them how they're supposed to be.
Okay. I understand those reasons.
No problem. Any other question? So the important thing is not just the working. The important thing is answering the question that is required. So yes, we'll probably say, oh yeah, man, me do this, I'm done, I'm glad me get it, yeah. And you don't answer a question yet. All right, so we have to focus on that as well. And so we are at the final part of the question, and you have been tremendously cooperative. I really appreciate it. Granted, I'll know someone know more and talk. But so the diagram below shows triangle OPQ, in which OP is equal to 3U and OQ is equal to V. Q is the midpoint of OR, and M is the midpoint of PQ. L is a point on OP such that OL is 2/3 of OP. It says that we're to find LM. And so there's some information that we know. When we're finding matrix vectors, LM simply means that we start at L, end at M, but we go through what is called a common point. So I'm moving from L. So I'm moving from L to M, but I'm taking this direction. So wherever I start and I stop, I pick up from there, and then I go to where I'm going. So it would have been L to P, and then P to M. And so we call this a head-tail situation. You start with a head, end with a tail, and then you join that head as a starting of next tail. All right? And so that is how we find what is called the resultant vector. Now, we have some information. If OL is 2/3 of OP, then LP is 1/3 of OP, don't it?
Yes, sir.
Are you there? Yeah, man. So OP really is 3U. It tells us that. And it tells us that from O to L, see it here, it is 2/3 of OP. Therefore, LP would have been the remaining portion of OP, which is going to be 1/3. We also know that since as Q is the midpoint, you with me? Sorry, Q is the midpoint of OR. So we're talking about, sorry, it should have been M. So PM really is the midpoint, which is half of PQ. Are you with me on that?
Yes, sir.
So we're trying to establish these two things. We're trying to establish LP and PM. All right. So L to P is 1/3 of OP. P to M is a half of PQ. We're good with that. Now, we do not know PQ. So because we don't know PQ, we're going to have to do some intermediary working as we go along. We know that LP is 1/3 of OP. And so to find PQ, in order to find half of it, we're going to go from P to O and then from O to Q. So P to O would have been the reversed order of OP. Hence, we have the minus of OP. And the minus of OP is going to be minus 3U because OP is 3U. So if OP is 3U, PO is minus 3U. Are you with me? O to P is given as 3U. We're reversing the direction. So it can't still be a positive direction if we're changing direction. So if O to P is 3U, P to O is the reverse order of that same 3U, which would have been minus 3U. Are you with me on that?
Yes, sir.
All right. And then O to Q is given as V. And since as we're taking O to Q as V, then V is correct. So in putting it all together, 1/3 of OP is 1/3 of 3U because OP is represented by 3U. And so we have 1/3 3U plus a half negative 3U plus V. And so we can work this out. All right. So 1/3 of 3U is going to give us simply U because the 3's can cancel. One is in the denominator, one is in the numerator. Good. A half of 3U is 1.5 3U, which can be written as 3/2. So a half of negative 3U is negative 3/2U. Are you following me? Anybody? Are you following me?
Sir, to be honest, I'm kind of lost.
All right, no problem, that's fine. So let us go back to, there is no problem in saying that you're lost here. So we're finding LM, which is the movement from here to here. So there's no pathway on this diagram that leads us directly from L to M. Hence, we have to go all the way around. When we start at L on our journey, we have to stop at P because that leg ends right there. And so we have to go at LP first and then from P to M. Are you with me on that so far?
Yes, sir.
Yes, sir.
All right, good. Now we have to use information given to us to be able to understand what LP and PM is. We know that LP is on the line OP. Because from O to L is 2/3 of OP as is given here, then LP is 1/3 of the line OP, which would have been the remaining portion of the line. Are you with me so far?
Yes, sir.
All right. Now, the information says M is the midpoint of PQ. So right here is halfway. So from P to M is halfway of the entire line. That's why we have half PQ. That is what PM is representing. Now, in order for us to put it further in context, we do not have PQ any at all. So because we don't have PQ any at all, it is something that we're going to have to work. So in working PQ, just like how we know that LM means that I start at L, go to P, and then from P to M, same thing. We're going to start at P, come to O, then from O. Are we together so far?
Yes, sir.
Are we together so far?
Yes, sir.
Mm-hmm. All right. So we know that from O to P is called 3U, and from O to Q is called V. Now, 1/3 of OP, which simply means 1/3 of 3U. Half of the negative of OP would be half of the negative of 3U, and OQ would simply just be V because we establish it from right here. Are we good so far?
Yes, sir.
Yes, sir.
All right. So 1/3 of 3U is simply U. Half of negative 3U is 1/2 of 3U, which can be written as a fraction as 3/2. So we're distributing the half in the inside of the bracket. Half of 1V is simply half V. Is that clear?
Yes, sir.
All right. So now what we're simply going to be doing is to combine like terms. If I have 1U and I need to subtract 1/2U, it means therefore that I'm going to still need half U to be able to finish the transaction. So U minus 3/2U is going to be minus half U. And so as I said before, I can't combine it with half V. So all I'm simply going to be doing is to write the positive one first. So write half V minus half U. And since as they both have a half as a common factor, I write half V minus U. Is that clear? Clearer? Follow at any
Yes, sir.
point? Anybody miss anything at any point? Wants me to probably just look at something?
Sir, the part where you have LM equal U negative
Mhm.
3/2, that part right there, sir.
All right, so is the calculation from the first part, 1/3 3U? What is 1/3 of 3? Anybody can answer.
3/2, sir.
Which is equal to 1, don't it? So I am, so basically 1/3 3U is just U, 1U. Now half of negative 3U is half of 3. What is a half of 3? A half of 3 is 1/2. Now that's 1/2. So 1/2 as a mixed number is 2 times 1, 2 plus 1, 3/2. Coming back to the very same question that we started out with when we had to change the mixed numbers to improper fraction. So 3/2 is 1/2. which is half of 3u. And because of the fact that we're distributing the half to each of the terms in the bracket, we also need to find half of v. And since v represents 1v, half of 1v is half v. And that's how we get the u minus the 3 over 2u plus the half v by calculating what is happening in the step above. Any clearer?
Yes, sir.
And then basically, we just simplify the calculation down here. We have u that can combine 1u minus 3.5, basically gives us minus a half. We write the positive one first, a half v minus a half u, and that is equal to a half v minus u. All right. So the question asks us now to find from P to R, which simply means that we're going to go from P to O and then from O to R. If from O to Q is V, what is Q to R? If O to Q is V, what is Q to R? What is Q of the line OR?
It's half the midpoint.
So Q is the midpoint. So if from O to Q is V, all right. So if O to Q is V, what do you think Q to R would be? What does the midpoint do to a line?
It cuts it in half.
Cuts it in half. Very good. So if from O to Q is V, what is Q to R? If you're eating a mango and you eat up to Q, which is half of it, right? And the side that you eat was called V. What would you call the other side?
V.
So if from O to Q is V, what is Q to R? I'm not telling you the channel. O to Q is V. What is Q to R? We're talking about building confidence.
You.
So if you eat half of your mango up to Q and it named V, what would you call the other side of the mango?
Sir, is it W?
What is wrong with you?
So
You have a red ribbon and you cut it in two. You have one part that you give to your friend. Your friend walks away with half of the red ribbon. What do you have left in your hand?
The other half.
half of the red ribbon.
Exactly. So why are you telling me half of the blue ribbon? If from O to Q is V, what is Q to R?
V, sir.
Thank you very much. That's what it has to be. It's equal. I didn't want to use the word because you must be thinking if O to Q is halfway and it is V, the other half now must be V too, don't it? So what is the length of OR? What's the full length of OR now?
Two V.
2V. Yeah, man. You don't have to guess, you know, you just don't have the confidence. You all know, you just don't. Come on, you have the confidence, man. And I mean, we could look at it from OP. If from here to here is 2U, then the other part has to be U because the entire line is 3U. So it gives you the information, but you can use the very same knowledge and decipher the information right here. All right. So in finding PR, we need to go from P to Q and then Q to R. So we've established that P to Q would have been minus OP plus OQ. We established that from over here. And QR, we already established what it is. So if we know that OP is equal to 3U, and we know that OQ is equal to V, and we know that QR is equal to V, then PR is equal to minus 3U, which is minus OP, because OP is 3U. And since as we want the minus of it, then it is minus 3U. We want OQ, which is V. You with me?
Yes, sir.
And we want QR, which is also V. Now, I particularly, and I mean coming close to the end, I particularly want you to tell me what is incorrect about the statement here. Can you identify anything that is incorrect? Can I identify any error in the working?
The answer, sir.
All right, so what's wrong with the answer?
It would not be 3V minus 3U.
What would it be?
It would be I know it would be V squared. I think it's negative 3U. Yeah,
Why did you say V square?
because there's two V's, sir.
And what are we doing with the two V's?
Multiplying them.
You sure?
Adding, sir.
If we're adding, would we get a square? If we're adding them, would we get a square?
No, sir. My brother.
All right, yeah, man, that good, man. No problem.
It would be 2V.
So it would be 2V minus 3U. Very good. Now, the fact that you're able to look at something and tell me the error and tell me the correction is telling me that you have the knowledge, you have the understanding. It's a practice that you need. All right. So it says that we're to prove that points L and M and R are collinear. All right, so when points are collinear, it simply means that they are a scalar multiple of the other. So one can be taken out of the other a proportionate amount of times. All right, so vector L, we don't know what it is, so we need to figure it out to be able to make the comparison. Because we have L to M, we don't have L to R. All right, so L to R would have been from O to L plus O to R. Now, O to L would have been 2/3 of OP. So we know that the negative of OL would have been negative 2/3 of OP. And we know that OR is 2 times OQ. We have established that already. So since we know that OP is 3U, and we know that OQ is V, then LR is negative 2/3 3U, which represents OP, plus 2V, or 2 times V, since as OR is 2 times OQ. And so the numerators, so 3's will cancel. 1 is in the denominator, 1 is in the numerator. So negative 2U, and we have 2V. So we can simply just rearrange by writing 2V minus 2U, the positive one first. And then if we look, they are a factor. 2 is a factor of both of them, so we can take it out. 2V minus U. And if we recall, LM is a half of VU. So it simply means that LM being a half of VU can come out of 2 times VU 4 times, because it's a four halves that make 2 wholes. You with me? So we can get 4 LM out of LR. So LR is going to be 4 times LM. And because of the fact that they are a quantity of each other, then they are collinear. One is a multiple of the other. So we say LM is half of LR, and we can say LR is 4 times LM. Being able to say that proportionate quantity in relation to the two of them makes the points collinear. You're a wonderful set. I hope and trust that you were able to learn something.
Yes, sir. We learn.
All right.